Welcome to Spark Academy. I am Nityanand Ghosh, Physics faculty here. So basically today I will be explaining you about the importance of units and dimensions. See, these units and dimensions you will be learning for all physical quantities, different physical quantities. So many situations are there, so many topics are there in physics. You have got mechanics, you have got electrodynamics, you have got modern physics, atomic physics, nuclear physics, and so many formulas will come. They are all derived quantities actually. So what are the units of those physical quantities that you need to know, and accordingly you will be getting the dimensions. Sometimes from dimensions you will get the units. So basically I will be explaining you about all this, what are the final details about these units and dimensions that I will be explaining in this today's class. Okay. Now, see, for any physical quantity, there are two types of physical quantity are there. One is actually very fundamental based. Fundamental means they are independent of each other. There are total 7 fundamental quantities. 7 fundamental quantities. It starts with MLT. M stands for mass, L stands for length, and T stands for time. They are independent of each other. You cannot mix them. You cannot mix mass with length or length with time. Independently, it can stand on its own. Actually, it cannot break it into this thing, smaller this thing. Length, mass, length, T. They are independent nature. Okay. Now, other physical quantities are derived in nature. Derived in nature means you have to, that particular situation you have to discuss. Suppose if I say force. Force, when you apply a force, a body will move with some acceleration and mass of the body is involved. So force will be mass into acceleration. You study that from Newton's second law. Newton's second law says that rate of change of momentum is equal to force, no? So that is all derived quantity. So derived quantities, derived fundamental quantities, they depend upon this fundamental independent quantities. Okay, fundamental independent quantities, these derived quantities they depend upon. So first let me know all the 7 fundamental dimensions. So 7 fundamental dimension is, of course I told you, mass is M, length is L, time is T. Then you have got electric current. Wherever electric current I is there, you know I is equal to Q by T. Unit will be Coulomb per second. You can measure it as ampere also. So ampere will be the unit. Instead of Coulomb per second, you can write ampere. Now temperature is K. In dimension you can put K. Dimension you can put A. Luminous intensity is measured in candela, CD. An amount of substance, mole. You know 1 mole of oxygen, 1 mole of any element, you know, and it is equivalent to Avogadro number of atoms, molecules, ions. So it will be measured in moles. So these are the 7: M, L, T, A, K, CD, and MOL. These are the 7 fundamental quantities. Now, these are all derived quantity what I wrote. See, these are all derived derived physical quantity. What is the derived physical quantity? Example number 1, velocity. What is the definition of velocity? Rate of change of displacement. Distance by time. Distance by time, L by T. L by T is nothing but T will go up. So it is M0 L T minus 1. This is the dimension for V. Similarly, what is the dimension for force? Force is mass into acceleration. What is acceleration? Acceleration, what is the dimension for acceleration? The dimension for acceleration is velocity by time. Velocity is what? LT minus 2. Velocity is Lt minus 1 divided by t. So it will be Lt minus 2. Okay, dimension for acceleration is Lt minus 2. So m into Lt minus 2 is the dimension of force. So therefore force is one physical quantity. Acceleration is also one physical quantity. M is also one physical quantity. Okay, so you put together and then you get. Calculate together you will get. Similarly, there are in one chart, no, there are several derived quantities are there. Here I gave you this thing, how you get the concept of force from Newton's second law. Newton's second law says that rate of change of momentum is equal to force, no, P is equal to mv. M you take common outside, dv by dt. dv by dt is acceleration. So force is equal to mass into acceleration. You can also get the concept of impulse also. Rate of change of momentum, no, dp is equal to f into dt. So large force acts for a short duration will give you impulse. Impulse is also equal to change of momentum. This is a very, very important equation for any competitive exam. So now, okay. So, what I want to tell you is that the system of units, there are this system of units. CGS system of unit, MKS, FPS system of units, SI system of units. You have to concentrate on these two, CGS and MKS. CGS में length, mass and time is denoted as centimeter, gram and second in CGS. In MKS, your length, mass, time will be units will be denoted as meter, kilogram, second. Okay, and FPS means foot poundal system, British system, foot poundal system. Length, mass and time will be foot, pound and second. Second of course is common. Foot is, you know, 1 foot is equal to it is approximately 30.45 centimeter, or it is equal to 12 inch. 12 inch means 1 inch will be equal to 2.54 centimeter. So these are all the conversion. By chance if they give in foot, you can get in centimeter, you can get in meter. Centimeter to meter means you have to divide by 100. And inch is a foot, centimeter also you can convert. And pound, what is the meaning of pound? 1 pound will be equal to roughly 1 pound. 1 pound will be roughly equal to 0.45 some 7 gram, or roughly 2 pound will be equal to 1 kg. Roughly. Like that there are different conversion. You have to concentrate on CGS and MKS, because in any competitive exam sometimes purposefully one physical quantity they will be giving in CGS system. Suppose they give instead of momentum kg meters per second, they will be given gram centimeters per second. So first you have to convert gram into kg or kg into gram. So one physical quantity in one system, work will be in other system. So first you have to be consistent. Convert all CGS into MKS or all MKS into CGS, then you solve the problem. Okay, suppose force is equal to mass into acceleration. Mass should be in MKS system. Acceleration also should be in MKS system. If mass is in gram and acceleration is in MKS system, and by chance if you try to multiply, you will get the wrong answer. Okay, so these are the different system of units that you have to. Okay, so in this actually in this chart, you know, the various dimensions are given: length, mass, time, temperature, mole, then area. Area is your some side into side, so it will be in MKS meter square. Your CGS में centimeter square. You know, density. Density is mass by volume. Okay, mass by volume means mass will be kg. volume will be meter cube. Similarly, CGS system, gram centimeter per cube. Suppose you take acceleration. Acceleration is velocity by time. So it will be meters per second square or centimeters per second square. Like that you have got kinetic energy, potential energy, work, power, pressure. All CGS system is there, MK system is there. Suppose you take force. Force, mass into acceleration. Mass is actually kg, acceleration is meters per second square. Also you can, the another unit for force, SI unit is Newton. And dyne is the CGS unit of force. Instead of taking gram centimeter per second square, you can write dyne. Then what is the relationship between CGS and MKS? Well, you know 1 Newton is equal to 10 to the power of 5 dynes. So all this conversion you have to know. You have to know that the conversion between urge and joule, joule and urge, and then dyne and Newton. Like that all conversion you have to know. Okay. So this particular tabular column explains you about the different physical quantity and its corresponding CGS and MKS unit. Now, here, here one example I have given. I will explain once again what is this all about. So it is in the exam, competitive exam, they are asking all this. See, what is principle of in dimension? No, you have to know the principle of homogeneity. What is principle of homogeneity says is that you know two physical quantity you can add or subtract provided the dimensions are same on both sides. For example, suppose if you have equation, let's say S is equal to ut plus half at square. Okay, you can this physical quantity you can add to this physical quantity to get S. S is some distance. This is possible only when all the dimensions are same. What is the dimension for S? L. What is the dimension for ut? This is also L. How? The dimension of velocity is Lt minus 2. Lt minus 1, sorry. And into T. Ut. So bases are equal, powers can be added. You will be getting Lt to the power of 0. That is nothing but L. Anything to the power of 0 is 1. Similarly, at square. At square A is acceleration. Acceleration dimension is Lt minus 2 into T square. So you will be getting L T to the power of 0, that is L. So this is the actually rule for principle of work. Similarly, V is equal to U plus AT. Okay, V Lt minus 1, this also Lt minus, this Lt minus 1. So you can add or subtract physical quantity. Suppose if you write V square minus U square is equal to 2As. So dimension of 2As is same as dimension of U square, same as dimension of V square. Then only you can add or subtract. So every year, no, they are asking, every year they ask that van der Waals equation, gas equation. Every year in your NEET or any exam, no, they are asking that question of van der Waals equation or gas equation. They ask the unknown quantity A and B. I will give one example. By using principle of homogeneity. So the equation is actually P plus A by V square into V minus V is equal to RT. This is one gas equation is there. This A and B, P is measured in pressure, P means pressure, V means volume, R means gas constant and T means temperature. This A and B is unknown, you have to find out the dimension of A and B first. So now they will ask what is A, B to the power of minus 2 or they will ask what is A by B. How will you find out? You apply the dimension of homogeneity. Dimension of homogeneity says that Dimension of B is same as dimension of B. B means volume. So what is the dimension of B? B will be equal to volume. B will be equal to volume. Volume is nothing but L cube. Length into breadth into height, no? So dimension of B will be equal to M0 L to the power of 3 T to the power of 0. This is the dimension for B. So we know B. What about A? The dimension for pressure is same as dimension of A by B square. So what is the dimension for pressure? Pressure is equal to force per unit area. Okay. So what is force? Force is mass into acceleration divided by area. So now what is pressure? Pressure is equal to force. Force is nothing but your mLT minus 2. That is force divided by L square. So this will give you m L to the power of minus 1 T to the power of minus 2. Pressure. Now pressure should be equal to, according to that principle of homogeneity, the dimension of P is same as dimension of A by B square. So P will be equal to A by V square. A by V square. So therefore what is A? A will be equal to P into V square. So dimension of P already we got. M L minus 1 T minus 2. So this into volume is L cube. So L cube whole square. So what we will be getting? M L to the power of 6 into L minus 1 is L to the power of 5 into T minus 2. This is the dimension for A. So you know the dimension of A, you know the dimension of B, you substitute in this and get the dimension. And in one competitive exam, they have given the dimensions as, they have not given in this particular form. They have given this AB minus 2 is equal to Planck's constant, or is it equal to angular momentum, or is it equal to energy density, or is it equal to torque? The answer is this, the dimension of AB minus 2 is equal to energy density. Energy density. What is the dimension of formula for energy density? The formula for energy density is energy per volume. So energy and work is same. Work is force into distance. So ml square T minus 2 is divided by L cube. And then you find out. So this will be equal to m L minus 1 T minus 2. So AB minus 2 is same as ml minus 1 T minus 2. So energy density you have to take. So several types of questions they are asking. This one question definitely they will ask in exam. So you have to use the principle of homogeneity and get the dimension for A and B. Now, so basically you apply dimension analysis to check the correctness of any equation. Suppose V is equal to U plus AT. Put dimension and check. Like that initially they checked. And then you can get a different physical quantity. I will give you formula for one different formula. You can derive different formula. I will give one example. So this is the example. This is the example. You have to derive the formula for simple pendulum. Simple pendulum, in your lab you might have done the experiment. You will be hanging one bob and you have to find out first the time period of that bob, and then you have to find out acceleration due to gravity of that bob. So point of suspension to the center of the bob, you have to take a vernier caliper and find out the diameter till the center radius from the point of suspension, length of the pendulum. So basically you have to actually derive this thing. So many questions they ask. You know, in summer the watch length of that pendulum will increase. time will decrease. Similarly, your and in winter it runs faster. So L will be having different formulas at time. So basically T is equal to 2 pi root of L by G. How you derive? Let's say tentatively, time period depends upon mass, time period depends upon mass, time period depends upon length of the pendulum, time period depends upon G. Proportional, let's say. So you equate that with some constant K, m to the power, you raise to the power of A, B, C. So you have to substitute the dimension for M, L and G. What is the dimension for left hand side? It is T. What is the dimension for T? It is M0, L0, T. M0, L0, T. What is the dimension for M? M, L0, T0. Anything to the power of 0 is 1, no? For completeness we write like this. Similarly, what is the dimension for G? Acceleration due to gravity. Acceleration due to gravity, the dimension of acceleration due to gravity is nothing but it is LT minus 1. It is normal acceleration only. You know, 9.8 meters per second square. So it is m0 L1 t minus 2. Then you substitute. Here t is equal to, in the first equation you wrote na, t is equal to m to the power of a, L to the power of b, and the dimension for acceleration due to gravity is LT minus 2 to the power of c. Now what you do, you collect the same powers, you know, of same base. So m to the power of L here one L to the power of c. So it will be L to the power of b plus c and t to the power of minus 2c. Left hand side. Now what you do, you equate the powers of m and t on both sides. If you equate the power of m, here right hand side a, left hand side 0. So a will be equal to 0. A will be 0 outright. Okay, then power of t is minus 2c. So minus 2c on the right side. Here the power of t will be 1. So c will be equal to minus half. Okay. Similarly, the power of L is b plus c. B plus c will be equal to, what is the power of L here? Left hand side 0. Okay. So b plus, what is the value of c? Minus half. B plus c will be equal to 0. So b plus value of c is minus half will be equal to 0. So therefore b will be equal to half. So you know b half, c minus half, you substitute back. So m to the power of 0, L to the power of half, G to the power of, anything to the power of half is actually root. So it will be root of L, G minus half will come down. So T is equal to K, T will be equal to K. T will be equal to K root of L by G. So T will be equal to 2 pi in K experimental this thing will be equal to L by G. Okay. So now, so there are some drawbacks. The drawback is nothing but for any constant, no, you cannot have dimension. Pi, 2, sin x, cos x, e power x, all this no dimension. And physical quantity, no, if that formula has too many factors, no, sometimes dimension fails. Okay, and this dimension does not distinguish vector from vector quantity from scalar quantity. Okay, so this is a chart wherein here physical quantities are there, here formula is there, corresponding dimensions are there. For example, suppose you impulse is actually force into time. So force is mlt minus 2 into t. So it will be mlt minus 1. Like that several physical quantities dimension. These also here several physical quantities: stress, strain, frequency, angular momentum. First you have to know the formula MVR. So M LT minus 1 into L. Okay, so this dimension is here. Like that, Young's modulus is stress by strain. So you put the formula and then you get the dimension. Similarly, this particular this thing also you have got different physical quantity and different dimension. Okay, so this chart, if you remember, then it will help you to whatever multiple choice they are asking. Sometime next slide I will explain. This is very important. What happens is sometimes they will ask in the exam which two physical quantity has got the same dimension. See, surface tension, force constant, same dimension. Here you see Planck's constant. Planck's constant means that formula E is equal to h mu. So h is equal to E by mu. E by mu. So E and work is same dimension. Mu is 1 by T. So T goes up. So work into T. So force into distance. So ml square T minus 2 into T. So ml square T minus 1. Oh, force into distance, so ml square T into T. So this is the dimension for the work into T. So this is the dimension. Like that, Planck's constant and angular momentum has got the same dimension. Here into TL, if you substitute, you will be getting angular momentum. Angular momentum is what? Angular momentum is equal to R into P, R cross P. So P ka dimension is LT minus 1, mass into velocity, MLT minus 1 into 2. So you will get the same dimension. So Planck's constant and angular momentum same, two physical quantities same dimension. Similarly, your stress, pressure, Young's modulus, different physical quantity same dimension. Torque, work, energy, same physical quantity, different physical quantity same dimension. So with this, these are the first basic part of your units and dimensions. So if you know all the physical quantity and their corresponding formula, and then you can design the unit as well as dimensional formula. You can get their dimension, and also you can derive